Hello, hello. Happy Saturday. STATURDAY. Chat live. It's good to see you all again after 2 weeks. Took last week off because it was July 4th here in the United States. So I took that weekend off, 4-day weekend, to get a little R&R and recharge, which has worked. Feeling good. So I hope you all are well. Wherever you happen to be in the world, whether it's here in the US or over in India or in Australia or in the UK, wherever you happen to be, it is very good to see you and talk to you today. So again, as always, these live streams are just casual chats. So I'm happy to answer any questions you might have. They do not have to be about statistics or anything like that. They can be, about the channel in general or just about a topic you might want to discuss. So I keep it, loose, whatever you want to talk about. I always commit to doing 30 minutes. It usually goes longer than that, but we'll do 30 minutes and see how that goes, because I have some other things to get to today, and I'm sure you do as well. So hello. Kieran, it's very nice to see you. Thanks for stopping by the live stream today. It's good to see you. So where are we at with the channel? Go ahead and drop your comments or questions in the chat, and I will pull them up on the screen, assuming they're appropriate, and answer them the best I can. So while I wait for some people dropping some comments into the chat, where's the channel? So I'm working on some new video content, and that will be out hopefully later this month, August, something like that. The way I've talked about this before, but the way my YouTube channel and other educational YouTube channels work is that the summer is like no man's land. Like views drop off significantly, subscribers drop off. I don't lose subscribers, but additional subscribers drops off significantly. That's because for the most part during the summer, the proportion of students that are in class is much lower, of course, in the summer. So I have some content that I might just kind of save up and then release closer to the fall when everyone is back in class, because no one's really in class right now. Not many people are in class. So that's probably what we're going to do. So let's see what we got here. Yogita, hi, good day to you. Hope you're doing well wherever you happen to be. It's glad to see you here in the stream. Thank you for stopping by. Let's see here. It's good to see you, my friend. Hope you are doing well. Hope life is treating you kindly. Let's see what we got here. Hello, Sanaz. Good to see you again. Thank you for stopping by again. Who else we got here? Alex, how you doing, my friend? Hope you're doing well, wherever you happen to be. Thanks for thank you for the wonderful learning. It's whatever I do in terms of my teaching always comes from a love of learning. I'm a learner first. And so I thank you for taking the time to watch the videos and learn, because time is the most precious thing we have. I always respect people's time. And if you spend some of your time with me on my channel, I am forever grateful, because you don't get those minutes back, So it has to be good. That's my goal. All right. Ajay, I'm not sure you pronounce your first name. Ajay. Good to see you, my friend. Thank you for stopping by. Thank you. Let's see, what do we got here? All right. So we'll get into some substantive comments and questions here. So this is a common question. So kickstarting my preparation for data science career. Luckily, my friend referred that later I got connected. Can you explain any steps on how to prepare for statistics? So, statistics is its own branch that sort of combines mathematics, of course, but also nowadays technology. It's a different way of thinking about the world, about measuring the world, making inferences about the world. So with statistics, as long as you have the prerequisites to learn statistics, which is, I think math up through algebra is fine, and you have some experience with probability, nothing crazy, but just some basic probability and things like that, and have some computer skills, you're ready to learn statistics. So the thing I think is important, and I tell everybody to do this, is to find the resource that resonates with you, that you learn best. So if you learn best from textbooks, Of course, I have many textbooks that I have, and actually many textbooks I work on in my day job. But there are online courses. There are obviously YouTube channels. There are many websites you can follow. So there's like Udemy courses you could take for that aren't that expensive. It's really just finding the best way for you personally to learn. You know, I learn best by switching modes of learning. So I might read a textbook, maybe practice some problems, and I might watch some video content that's kind of like a demonstration, show me how. And then I might do something a bit more like experimental. Like it's not above me to go up in my kitchen and grab something I can measure and like do like statistical tests on stuff like around the house just to see if there's like any difference. Like M&Ms, I did some experiments with M&Ms once, so you can do your own experiments and design your own experiments and measurements, So there are many ways to learn statistics. It really just depends on how you learn best. And sometimes it's more than one way, So just be a seeker. Seek out how you learn best is my advice on that. So if you have any other questions that I can clarify, feel free to drop them in the chat and I will elaborate if at all possible. All right. All right. So, Harini, hello. It's good to see you. Good to see you. Thank you for stopping by. Aluwafemi, did I get that right? I hope I try. Like I always say with every live stream, I try to get everyone's names correct. Of course, I don't always do that, so I do my best. If there is a problem, just let me know. Let's see. All right. Yeah, this was kind of Vainbow. Good to see you again, my friend. Hope you're doing well. It says I once flipped a coin 500 times to test if the binomial converges to normal. Yeah. So, yeah, I have a set of dice over here that I sometimes use for little experiments that I've done. I've done videos in the past that involved playing cards, here and there. So there are different things you can just try out around where you live or out in nature or wherever you happen to be to see if you can generate your own data and do some hypothesis testing on your own, So a weird thing about me, one of the things I find most interesting is the mathematics of traffic, like the flow of cars on the roads. Something about that I've always found fascinating. So I've thought about actually looking out my window or going somewhere like an intersection and like counting the cars that go through or whatever else, because that's what I do for fun, So that's how strange I am. So you can do your own experiments, all right? Absolutely. Let's see here. Trying to get some of the introductory comments out of the way. Oh, lots of comments coming in. So let me go through here. All right. So Frank says, great to see you. Hope my students often make the mistake to accept the null hypothesis with the 1 minus alpha confidence when there's not enough evidence to accept the alternative. Yeah. Or you have to do some power test or control for that. It's a common mistake, right? Because at least here in the United States, my take is that we don't grow up thinking like this. We don't think in terms of how we accept or fail to, or how we reject or fail to reject our everyday reality, the assumptions we make about it. So hypothesis testing can be very confusing for students. And confidence intervals are some of the most confusing things to try to explain, only below degrees of freedom, which is really difficult to explain to students who are new to statistics. When it's like, why are we dividing by n minus 1? Or what is a degree of freedom? That's a hard topic to try to explain in an easy way to introductory stat students. So confidence intervals are another one. Hypothesis tests like this are another one. So unless we control for type 2 error, yeah, we have to do these the traditional way. All right. Oh, Lord. Let's see here. Lots of comments today. I love it. All right. So couple of things here from Mauricio. I think I got that right, Mauricio. So Mauricio says, hello, Brandon. I have a data set of companies containing, good to see you again, by the way. Data set of companies containing both numerical and categorical data, city size, annual sales, etc. There are no target variables, so we automatically know what we're limited to. What method would you recommend me to use for clustering this data in order to extract some insight stakes in advance? There are no easy answers to this. You can do traditional k-means clustering. You do hierarchical analysis. You could, what else could you do in terms of the unsupervised type of stuff? Top of my head, what would be a good one for this? Let me open something up, and I might have another suggestion. 1 second. I'm gonna open up this other thing on my computer. All right, so I'm waiting for that to open up. So you could do hierarchical clustering, of course. K-means would work. PCA could be a way of clustering, of course. There are other ways to go. Leuvian clustering is probably a bit more advanced. So there are different ways to do clustering, but I would tend to say that things like k-means and hierarchical clustering are the most common that you could use. And PCA, I guess. So, all right. Oh, let's see. Kickstarting from there. Data science, kickstarting from there. Discrete probability. Yeah, so I think if you're going to go into data science and want to go into, algorithm creation and stuff like that, then you're going to have to learn all of statistics, not just, I'm not saying you are, like just discrete probability. But obviously, when you're doing ML models and stuff like that, the best place to start is in typical linear regression and logistic regression. So quite often, when you're going into a classifier, good old-fashioned logistic regression is often the best model. So definitely learn what that is. And then as far as other type of things, like when we're doing working with categories and testing the models and we get the confusion matrix, sort of understanding the probabilities involved in some of that is a good place to start, of course. So it really depends on what you want to do. And of course, if you're doing data science, you're going to have that coding background, whether it's R or Python. I think most of what I see is a movement towards Python. But obviously, I'm pretty sure you would know that already. So you got to kind of combine everything, in my opinion. Let's see here. Let's see. Have a doubt. Be ready if you can give me the answer. Is there any method to identify what causes the overfitting? The cause, well, identifying the overfitting is the first step. The cause of the overfitting can be too many variables. So if there are too many feature variables, we're going to capture some of the noise in the training set. And then when we expose that model to the test set that doesn't have all those nooks and crannies and idiosyncrasies that are available in the training sort of set, we can, well, that would be, I guess that would be underfitting. So the mismatch between the training and testing set can be the cause of that. But if we have too many variables in there, then the model will overfit the training data, right? And then you go to do it on the test data, and it doesn't fit very well. So the model overfits that training data. It could be from too many feature variables. So identifying which feature variables are really important can reduce that. You're going to have a model that's more generalizable if you do that. Remove any extraneous feature variables is a good start. And really just a lot of the exploratory data analysis up front would be good. Let's see here. Talk more about probability density. So cumulative, Probably in PDF. So lots of different things we could talk about if we're talking about sort of in a normal distribution sort of setting. Okay, so the probability density function is sort of a point on the curve that represents a probability with a specific point. Of course, cumulative is cumulative in that distribution. So it really depends on the application here. But yeah, and if we're talking about kernel densities, then they're not going to be obviously normal distributions probably. So there's a lot of things we could talk about in there, but I'm not exactly sure what we want to discuss about cumulative and probability density functions. Let's see. All right. Doing a great job. Thank you. You are doing a great job too, Ria. Let's see here. Experience in developing deep learning applications. I want to shift my career from the application side to actually building deep learning models. Can you tell me where to start learning for the right shift? Well, you have experience developing deep learning applications, so you obviously have. I'm a bit confused. I have experience developing deep learning applications. Shift career from application side to actually building deep learning models. Start learning for the right shift. Well, to build any sort of model, whether it's a very basic ML model to like a deep learning model, is really to understand the background and the data engineering and stuff like that need to go into building that model. It's really important to understand what variables you're putting into the model and what it's going to do for you, what it's not going to do for you in the end. Whether or not you want to learn the mathematics of some of that is really up to you. I'm not convinced that's a good use of time necessarily. But if you want to go into mathematics, you can do that. So there are many resources for learning ML and sort of other, I know deep learning is something a bit different, but a lot of Coursera courses, Udemy courses, obviously on YouTube. There are plenty of places to start. So again, find the one that works best for you and give that a try. And then if it doesn't work for you, then you can try something else. So you can just find the resource that works best for you. It's the best advice I can give. Let's see. I do get this question, so I'm going to go ahead and answer it now. Possible to have your scientific support to publish a scientific paper according to statistics and machine learning. So now I appreciate that, but I do not do that kind of work. My background is in education. There are people who specialize in statistics and ML and other things that actually have, advanced degrees in those things, who are better for that type of thing. So, I learn things because I love to learn them, and then I share that learning with other people. So that's kind of the way I approach all of this. But if you want someone to consult on a scientific paper, you're much better off going to someone who actually has academic expertise or PhDs in those topics. And you can find people like that on LinkedIn. You can find people like that. I'm not sure if, not Fiverr. There's probably some other site out there for consulting. You can hire consultants probably. But this is not really my ballpark. So I have answered questions for individuals who have a quick question about a problem they're working on or something like that. As long as it takes like 5 minutes or so, I'm more than happy to answer someone's question on LinkedIn, but this is probably beyond what I'm comfortable doing. You should get a real consultant for someone like this. Let's see here. What else do we got? I'm just checking the comments here. Let's see. Mario. Those have a two-way ANOVA. Factor A has 3 levels, so factor B has 2 levels, so we have a 3x2 two-way ANOVA. The interaction is significant. How can we know which of the 3 possible interactions are significant? Well, you test them all. So In a lot of software, whether it's JMP, Jump, or I'm sure probably Minitab or other software probably has this. I'm sure there's probably a package in R that does this that will allow you to test all interactions up to however many terms you want. So you can try all the interactions to see which ones are significant. So yeah, just test them and see what comes back as significant. And two-way ANOVA can take different forms. Okay, so obviously block, repeated measures, there are different ways to do two-way ANOVA, so that would kind of depend on that too. All right. Posthoc for interactions. I'd have to check into that. I'm not sure if there would be a posthoc for interactions. I might have to look that up. Let me get back to you. Mario, just send me a message somewhere and I can research that. I have not really come across that, to be quite honest with you. So I'd have to look that up. The thing about all this stuff is not all of us that do this for a living don't have all this stuff in our heads, like in the front all the time. We have to look things up. It's like someone who's writing a piece of code and goes to Stack Overflow, right? We don't have it all right here. So if there's something that I can't answer right now, I can always look it up if you drop me a message. All right. What else? Frank, is there a non-parametric alternative for the t-test for two sample means? There is. There are many parametric tests, and I could look it up. And they all have names, like Friedman test and stuff like that. See, y'all make me do this. Pull out a damn book. Y'all are evil. I didn't mean to be flipping through a book for this. Maybe I won't. So the Kruskal-Wallis and the Friedman test depends on how the problem is set up. I'd have to look. But yes, the answer is yes. There are non-parametric versions of parametric tests. So yeah. I mean, the basic is the sign test, Wilcoxon sign rank test. So just had to look up your particular your application. But in general, there are non-parametric alternatives for almost every comparison of means. So you just have to find the one that applies to your situation. Let's see. If some of you are answering very specific questions about a specific problem, and there's no way I can, answer those off the top of my head. So you might have to just message me and I can maybe look it up for you. All right. What else do we got here? For a business, Venkatesh, good to see you. For a business analyst, how much math one needs to know? I tend to think from what I understand, a traditional business analyst and business analysts that we have in the company I work for, and just students that are taking courses to become business analysts. So I work on a business analytics textbook that I have over here. So this is the business analytics book that I'm part of the product team that we work on this book. And if you flip to this book, this is the market leading by far. It's a huge book. If you're looking for a good business analytics book, this is the one. There's not a whole lot of math in here. It's much more about knowing what tool to use or what technique to use based on the business problem you are trying to solve, then knowing how to implement that, and then knowing how to communicate that to whoever the stakeholder or end user is. There isn't a whole lot of, manual math in a business analytics sort of context. It's really about problem solving and communicating, So this focuses on descriptive, predictive, and prescriptive analytics. but it's more about the back half of that, not the mathy end. So in here, the philosophy is let the computer do the math. Is what this sort of the honest it is. Now you can learn the math if you really want to, but I don't necessarily in the traditional business analytics context think that that's necessary. And we all only have so much time. So maybe the best use of the time is working on the problem formulation, figuring out a technique to solve that problem, implementing the solution to that problem, interpreting the results you get, and then being able to communicate that to the stakeholders, right? So how much math do you need to know? Traditionally, I don't think you need to know much, but there's nothing wrong in learning it. All right. All right. All right. Trying to go through here. Yeah, Ria says, I built applications using pre-trained models. Gotcha. But you want to build this kind of model from scratch. So instead of using a pre-trained model, you want to develop your own model based off some training data. So absolutely. So you can, doing deep learning applications, you can sort of start there. Let's see here. Yes. So Ankit, yes, Frank, you can use the Mann-Whitney test. I think it's one of the ones. I think it's one of the ones I mentioned here. The thing about parametric tests, they're all named after some like people, so it's hard to keep them all straight in your head. And honestly, non-parametric statistics is underutilized. We tend to focus on traditional parametric statistics. Non-parametric statistics is actually very powerful and can do a lot of things. When we have assumptions we cannot, verify, but we don't use it very much. So it's not like in the front of the head. So yes, the Mann-Whitney test is one of those. And actually, I think the Mann-Whitney actually goes by more than one name. One of these goes by two different names. It's the same thing. So I got to check on which one that is. So yes, good. Yes. So the data is not normally distributed, which is why we use non-parametric statistics. So you need the alternative test. So yes. So if I go back up, this is a very good point. If I have the original one somewhere. So yeah, so we go from here, non-parametric alternative to the t-test. Yes. Mann-Whitney, which I have a video on, by the way. Yeah, so I have a whole playlist on non-parametric tests. If you don't know that already, I do. So you can check out those where I kind of walk through how this is the non-parametric equivalent of a traditional parametric test that we are used to and why we use the non-parametric version. Okay, so if you want to learn more about non-parametric statistics, you can follow that. I think every video has the Excel file you can download and follow along and practice along with me. And we walk through it step by step by step. Like we do all the ranking by hand. It's all fairly manual, so you can see how it works. All right. Let's see here. All right. Lots of comments to get through here. So, what is the publication and authors? The business analytics book. So, again, this is my day. This book is what I work on in my day job. I'm not here as a spokesperson for my day job. YouTube and that are two separate things, at least in theory. So I'm not here trying to hawk the books I work on, but at least here in the US, this is the by far huge market share in business analytics. So it's Cam, Cochran, Fry, Ullman. So this one I work on a lot in my day job. At Cengage. So there's courseware and everything. So this is the business analytics book, my friends. So if you're looking, this is the fourth edition. I'm sure the fifth will be out relatively soon. So you can find the third edition and this fourth edition you could probably find used somewhere, but it's fantastic. They write very well, very clear. If you like the way I teach on YouTube, you will like all of the books in this series. And if you go to my LinkedIn profile, in the header, you will see all the books that are all part of the same author team, from stats to business analytics to management science. We have a new data visualization book that just came out. It's a whole kind of like a whole family of titles. So, and we do other books. We have other books too, of course. So, all right. I'm gonna look through the chat. I'm gonna sip my tea because I've been talking for a long time. Let's see. Just looking through here. All right, see if any other comments I missed that I can answer. I don't pull every comment up on the screen because some of them I just can't answer in this sort of setting, but I'm more than happy to respond if you message me on LinkedIn or YouTube, and I'll try to look it up and give you a proper answer instead of me pulling it out of my butt. All right. All right. So what else do we got here? Elaborate on about what kind of inventions people make, patent, in AI or ML algos. If I think I understand the question, Vasanatha, is, are you asking like if someone builds a model and they patent it, so they own the model? Is that what you're asking? If that's the case, then it really depends obviously on what country you're in and how the laws work. But many companies obviously have proprietary algorithms. Google is the number one example of that, right? So the Google search algorithm is like the formulation of Coca-Cola, or, the specific mixture of a chemical that a company has invented, or the formulation of a medicine that has a patent. So there are many examples of companies that develop models that are their proprietary intellectual property. And, how you create them and patent them really depends on what sort of country you're in, and so on and so forth, but can be very valuable and lucrative. But it's actually a very interesting question. I'm not sure how the patent process, if that's what you're, again, talking about, like patenting, like intellectual property of a model you have created, if that's what you're referring to. So, all right. What else do we got here? If that's not what you're asking, let me know and I can clarify the best I can. All right. I'm going to scroll back up here, see what we got. I think I got most of these. Let's see. So one question. Oh yeah, so interesting question. Any reason why linear discriminant analysis is not quite popular, unlike logistic regression, random forest in the data science community? There are a lot of techniques, and LDA is sort of one of them, that I think kind of have gotten out of favor just because there are just better ways of doing things. There are many statistical techniques that were invented in the context of the mathematical knowledge at the time, the mathematical ability at the time, the computing power at the time, of course. And what just happens is, like, just over time, certain techniques and models just become more popular because they're better. They are more robust, or they are easier to interpret. They are easier, and like, especially in this case, like logistic regression is very easy to interpret because it's just like interpreting regular regression in many ways. So they just get chosen and used. So in many statistics textbooks I come across, linear discriminant analysis isn't even in the book, like, at all. So it might have just been a transition or a technique that has just been improved upon and something has taken its place, which is science. That's just the nature of science. So, and some of it's like sizzle, like, logistic regression, because it is easy to set up and interpret, I think is very much favored. And honestly, it's often the best model to use. Um, Random forest is more of a black box, but once you understand decision trees, random forests are just another few steps to understanding, so they're not that hard to understand. I love decision trees, by the way. So, yeah, it just depends. The evolution of fields, some things just get out of favor, some things come back in. One kind of example of that, it never really goes away. So one example right now is the reemergence of SQL in the data science community, which after for a while you didn't really hear about it. It never went away. It was always there. But now we are realizing we have all this data. We generate just so much data. Every second we generate so much data. Now we got to figure out how to go in and grab it and query it and put it together and maybe transform it. So now SQL is very important again, right? So some of these things just come and go, and who knows? LDA might come back, or a different version of it might come back. And sometimes there is no best choice. It just depends on your application. And there's no, if you use LDA, nothing's keeping you from also doing other techniques. You can try them both. So, but I think logistic regression and random forest have just risen the tide of the machine learning wave, right? So when they can be implemented like that, like techniques kind of ride the wave over the past 5-10 years. And I think that might be the case here too. Let's see here. Access the sources that you have been shared. Is there any specific one you're referring to, Sanaz? If you're referring to this book, you can find it on Amazon. You can find it on used book websites. You can find it pretty much, as well. So you can find it anywhere if that's what you're referring to. If you have something specific, just put it back into the chat, Sanaz. I can tell you where to try to find it. Yeah, so LDA can be used for multi-class, so binary regression, but there's also multinomial logistic regression too, obviously. So yeah, I'm not a huge fan of multi-class targets. I think they're unavoidable in some circumstances, but always when people ask me a question about having a multi-class, more than two categories in their target, I try to get them to maybe rethink their design study because it just gets really messy when you have multi-classes. But yeah, so LDA can go, but multinomial logistic regression can be there as well. All right. If something, a technology algorithm in medicine is proprietary and patented, how does it impact the democratization of the same? Very good question. So this is a perennial back and forth when it comes to the openness of certain inventions or intellectual property. The most famous one I think right now is the intellectual property around scientific journals. So, a lot of them are taxpayer funded, at least here in the US. And then you have people who put them behind paywalls. And it's like, well, who should have access to them? The idea behind, patenting technology, or it's an algorithm or medicine or whatever else like that, is to incentivize progress. So if someone can invent something and create something, and for a time can solely benefit from the fruits of their labors, then that encourages other people to do the same. And the thought process is that it moves things forward because it incentivizes that, at least for a period of time. Now, people abuse that process. There are patent trolls. There are ways to get around the process. Like in medicine, you can like alter one molecule and it's a different molecule. So you can basically patent the same thing over and over and over and over again. So, but the idea is to incentivize invention and progress so people can benefit, or companies can benefit from the R&D investments and things they make to make things. So at least that's how it's supposed to work. In theory, it doesn't always work that way, but that is the thinking. And here in the US, patents and copyrights aren't, most of them, I don't think, are forever. They expire after a while. So it goes into, you have generic medicines, you can do stuff like that. Now, algorithms, I'm not quite sure how that works, how the patent time frame. Let's see here. Yeah, this is a lawyer question. If intellectual property rights not an issue, I'm assuming we are able to create a custom algorithm by tuning certain parts of already existing algorithms and patent it. Kindly correct me if I'm wrong. Case why people are still not flooded with patents. Yeah, see, it's like this is a legal question. Patent law is a very complex area of law. It's country specific, and a take on something, there are requirements. Like you can't go out and patent like logistic regression, right? Now, you can obviously patent models that use logistic regression. So I think it has to be something bigger, right? It has to be some sort of process or flow to get that sort of patent. But that's a legal question that lawyers can answer and other people probably would know more about. But there's probably a gray area in there where if you change something enough, it becomes something new that you can then claim a patent on. Let's see here. All right. Let's see. Ridge or lasso, depends. What kind of penalty do you want? That is really up to you. Have to see the application, but what kind of penalty you want. All right. Well, I think about the book Business Stats by Ken Black. I have that. I have an older edition of that book, I think. So this is woo! There we go. This is an older version. There's a glare. Sorry about the glare. This is the Black book. Actually, the company I work for used to work on this book. That no longer does. So I've had this older edition for a while. I like it. I like the book. It is have a lot of Excel in it. At least this version does have Excel in it. But yeah, I like the Black book. Problem is there are only so many books you can really do and put out there, So, but I definitely use this as a reference. The Ken Black book. So, all right. Probably do a few more minutes here. I'm gonna head up. So after this, I'm gonna head up to the coffee shop and work on some more videos. That's what I'm gonna do this afternoon. All right. This is a very good point. So AutoML changing the landscape going forward. Yes. So as a lot of these things become automated, and people are developing packages in Python that automate this process too, that can try all kinds of iterations and permutations of parameters, hyperparameters, and stuff like that automatically. Can try ensemble models and do everything just with a click. So that will be the AutoML landscape is going to change, some things. So that's a very good point. That's a very good point. I think of the book Business Analytics by Dinesh Kumar. I am not familiar with that one, but I will check that out. I'm going to get my pencil, and my notepad here and check that one out. There aren't a whole lot of business analytics books that have been around for a while. Let's see. B.A. Kumar. Got that on my notes. You all always have great ideas for me, so I always write them down. All right. What am I working on now? So on the YouTube channel, I'm working on continuing videos about model building techniques and how to choose the best model out of all the ones that can be given to you, like in best subsets regression. So we're going through techniques one by one to talk about each technique. So I've already talked about adjusted R-square, working on a video about standard error of the regression. And then there are others like Mallows, AIC, and stuff like that I'm working on. So yeah, I'm going to continue that playlist until it kind of runs its natural course. And then I'm going to pick a new topic to start on. That might be time series. A lot of people tend to want time series videos, which I think is interesting. I enjoy time series analysis. It's, obviously there's relation to regression in there. So I might do that. People have asked for things like design of experiments. So that's always an option. But again, YouTube is not my full-time job, so I just do it when I have the time. And I can't devote, all day, every day to it because it's just something I do on the side because that's how much YouTube pays. YouTube pays me enough to do it on the side. All right. Here for the first live chat. Now I'm back. Thanks for your videos. Got my master's in neuroscience and we'll be starting a PhD in neuroscience and data science. Have a good, awesome. Everybody give a clap. Congratulations. That is awesome. That is awesome. So yeah, like, Vainbow, thank you very much. Time series, time series. Yeah. So I'm probably leaning towards doing some videos on time series, more in-depth videos on time series. That seems to be I would guess from what I can tell, the most popular request, after finishing some of this multiple regression type stuff. Probably I have enough video ideas and content I'd like to create that will last me the next 5 years easily. I have plenty of ideas that I want to do and the way I want to approach it. It's just a matter of time. I would love to spend all day, every day making videos for all of you. But when the expectation is that education is all free, you can't make a living doing it. So unfortunately, I can only do what I can. So, all right. So we're getting up near 50 minutes here. So if you have any last questions, now is the time. Because I definitely like to wrap this up within an hour because you all have things to do today and I do too. So if you have any other questions, now is the time. So let's talk. So while I'll wait for any last minute questions, sort of what's coming up. Yeah, Frank, so much fun. Time series analysis, many ideas, important topic. Absolutely. So that's what I might do next. And like when I pick a topic, I kind of focus on that topic for a while, and run the playlist to a natural end. I don't like to jump around topics. I like to get in a topic and make videos on that topic through its natural course of time and then pick a new topic. It's much easier to do because the videos flow, right? Oftentimes when I'm doing a video, I actually start with the content from the previous video and I like delete out certain parts and then start from there. And I keep doing that process until it comes to its sort of natural conclusion, natural end. It's much more efficient to do it that way. So I think time series. All right. Bold of you to assume I have a life outside of stats. Yeah, exactly. George, thanks for all you do. Thank you for what you do, George. I appreciate your comments and for stopping by the channel and spending your valuable time learning with me. So Marwa, I'm a pharmacist and went for a master's in health economics. I seriously was lost in econometrics until I found your videos and made it through. I really can't thank you. You are very welcome, Marwa. That's why I do it. I do what I do to help people because I love doing it. I love learning. I love teaching. And if I can share that with the world and help people in the process, then what is the downside? You know, I only wish I could do more of it. So really, the thanks is all mine because you came to the channel and got the help you needed. You put in the effort, you put in the time, you put in the struggle and worked your ass off and you accomplished. So the real hero is you. It's not me. You put in the time. So congratulations. Let's see here. There are some things here. Randomization reduces the bias, but applying business rules introduces bias. How do you address this, please? I'd have to see the exact application you're referring to, Manjanatha. But in general, my general response to questions like this is just to acknowledge it. So if I'm writing something up or communicating something, and I have to implement a process or a technique that I think might influence the results or might bias the outcome, not bias mathematically, but also bias just in general bias sense, and it's unavoidable, the best I can do is just point it out to people and say, hey, I had to do this or I had to do that, and therefore, these results may not be indicative of the entire population. So I look at data all day in my day job. I look at, student usage statistics and stuff like that. And I know that I am only getting part of the picture when I do the analysis. And all I can do is acknowledge that and realize that it may not be the full picture, or I had to make some compromise somewhere. So I think transparency is the answer. That's my best answer, transparency. All right. The channel was invaluable to me during my undergraduate statistics course. Thanks a lot. Pawan, you are very welcome. It's my pleasure to help you out on your journey so you can get on the next step of your journey. I'm just a bridge, So my channel is just designed to help you get from here to here and then on your way. And then you can wave back to me because I want to see you off in the distance on the next leg of your journey. That's what makes me happy. So, how to start our career as a beginner in data analysis. So I get this question a lot. I think it is I would recommend people take a multifaceted approach to beginning data analysis. So obviously, learning the mathematics and the techniques, whether it's statistics or ML or whatever type things you want to learn about. Also learning the computer side of things, whether it's a programming language like R or Python that you want to learn, or a proprietary piece of software like SAS or whatever else it might be. You got to learn the technology side, but also encourage everyone to read widely. So if read the newspapers, read popular books about topics in data analysis and business in general, or in whatever field you want to do data analysis in, and get a holistic view of it. Not just the mathematics and the stats and the computer stuff. Yeah, it's great, but become a professional in the field you want to do data analysis in, and read widely, read deeply in that field, in the discipline. And obviously talk to people who work in that discipline as well, and get that well-rounded, holistic view of the field you want to do data analysis in, to know where you sit in there. Because, my $100 tip for the day is that there are many, many people out there learning all the algorithms, how to code and program, stuff like that. But the real valuable people in a business are the people that understand the business, that understand the market, that understand the forces, the tensions in the market, understand their customers, They're end users. Those are the people that are valuable in any company, not just learning the mathematics or the coding background. So, okay, that's my soapbox and my rant. Sorry. Gaurav, what do you do professionally apart from YouTube? So my day jobs, I work for Cengage Learning. So we're a higher education. We do a lot of things, but the bulk of the company is higher education publishing. So we make textbooks, but nowadays we make the courseware. So when college students go to their class and they log in, we have MindTap and WebAssign are our online systems. They log in there, their ebooks in there, their homework is in there. There's all kinds of activities in there. So I help develop the digital side of that. That's my day job. So it's backwards. So like, again, I have this, I work on this book. I work on a series of books in this family, but I do the digital stuff. And then YouTube is on the side. And then I do training courses. I narrate training courses on the side as well. So I have one full-time job and 2 part-time jobs, which is a lot. And I have my own house I got to maintain, which is definitely a first world problem. I mean, I have my own house. It's a modest, small house, but I got to do that, and just a lot of time, So, and I try to relax. Since COVID, COVID is a horrible thing for millions of people. Over 4 million people have died from COVID, and millions more have been affected by it. Personally, the isolation from COVID was a good thing, because it made me slow down and focus on what's important in my life, what I love about my life, what is meaningful to me. I've lost over 70 pounds in 1 year, almost to the day. I've lost over 70 pounds because I could control my food. I could exercise. I could get rest. I could relax. So that's been good for me. So my work life is just one aspect of my life, and I try to definitely slow down and walk in the park and just take it easy to enjoy the time I have on this earth, which for all of us is finite. Not to be morbid, but it's finite, and we just have to live and be happy. So I work at Cengage, do YouTube, and do training courses, and those 2 are 2 part-time jobs. So, all right. Let's see. Yeah, so lost over 70 pounds in a year, and just making healthier choices, and working from home has allowed me to control my own schedule. And as much as I love the office, which I bought this house because it's right by the office, and now we aren't in the office, which is kind of funny. But at the office there was people would bring in donuts in the morning, or they'd order pizza at lunch. There's a food court downstairs. There were food trucks downstairs. There were fast food restaurants across the parking lot, and it's just so many bad health things were just there. But by working from home, I've been able to control my diet. I've done what's called Nutrisystem. Some of you might be familiar with Nutrisystem. I exercise 6 days a week now, walk at the park, and it's also affected this mental health, So just being able to get outside and exercise and relax has been a godsend for me. So I can't imagine ever going back to an office full time. I mean, I may have to, and that's the world. And if our office goes back full time, that's what I'll do, or whatever else it might be. But I'm just so happy to work from wherever. I love working in coffee shops. That's my favorite. Thank you so much for videos. Have a great weekend. You too, Venkatesh. You have a great weekend as well. Matesh, thank you for Stats 101. Hope you got your drone fly. I did get my drone flying license. So I passed the test. First time, is it 2 weeks ago? I think it was 2 weeks ago, with a 90% on the drone flying test. So I am a certified drone pilot with the FAA, which is the Federal Aviation Administration. And I can legally fly my drone in certain areas and at night. So that was really fun. So I'm looking forward to the weather cooling down a little bit so I can go fly my my drone in certain places. So yes, I'm very excited to be a certified or a licensed drone pilot because now I can actually make money flying my drone. So if I have neighbors that want pictures of their houses or something like that, I can charge them $50, $100 for videos and pictures of their house, and that's legal now because I have my license to do it. And I've always wanted to fly. Like if I could be any animal, it'd be like an eagle or a bird because they could just fly wherever they want. All right, one or two more questions, and we're going to wrap this up so we can all get on with our weekends. How does data science help to navigate the new normal post-COVID era? Not sure how to interpret that question. I can think of one way. Oops, knocked my microphone. I think one way is that COVID has accelerated changes that were already happening pre-COVID. So once COVID happened, everyone was working from home. A lot of learning obviously went online and was totally online. Anything that could be done at a distance was done at a distance. And that was already happening, but I think COVID made it happen faster. So data science obviously plays into that because a lot of these automated systems, these online systems, these software of service type systems are data science and, algorithm driven and stuff like that. So I think the new normal is going to be a more at a distance, more automated type environment. And COVID just accelerated that. And of course, data science will be an important part of that. Right. Thank you so much for your great, you are very welcome. It is my pleasure. So, all right, we have gone just a tick over an hour here. It flies. Time absolutely flies. So what I want to do is wrap this up. Now, I didn't get to every single question. There's no way I can get to all of them. Some of them I can't pull off the top of my head. If you want to follow up with me, you can message me on my website, YouTube, or LinkedIn is usually the best. And if it's a quick question, I can answer it. But, I can't. If I answered every question I got on LinkedIn or something like that, like people send me papers to consult. I would love to do that, but I just don't have time. So if it's a quick question, you can reach out to me. Okay. So yes, thanks again. You have a great weekend. You as well. Denny, thank you for live session. Insightful. Have a safe, great one. You too. So everyone, it is a pleasure seeing you again on this Saturday. I will see you again next Saturday, barring anything weird that happens. And we can talk again then. So wherever you are in the world, I appreciate everything you do for the channel, and it's so great having you. And I hope you have a great rest of your weekend. So take care. Bye-bye.